Good morning, dear students. So this is part 2 of the chapter motion, and the topic is uniform motion and non-uniform motion. So how will you differentiate between uniform motion and non-uniform motion? Consider this example. Here the object starts from point A and reaches up to point B. The distance between A and B is 5 and the time taken by the object for this journey is 2 seconds. Again the object starts from B and reaches up to point C, and again the distance is 5 and time taken by the object is 2 seconds. Then the object starts from point C and reaches up to point D. Here also the distance is 5 meters and time taken by the object for this journey is 2 seconds. So you might have noticed one thing, that here the object is covering equal distance in equal intervals of time. So this is uniform motion. Fine. Next is non-uniform motion. Non-uniform motion is when the object covers unequal distance in equal intervals of time. As you can see here, the object covers 6 meters in 5 seconds and next 2 meters in 5 seconds. So unequal distances in equal intervals of time are covered. So this is the case of non-uniform motion. Next is the case of measuring the rate of motion. So the topic is speed. So as you all know that different objects may take different amounts of time to cover a given distance. Some of them move fast and some move slowly. The rate at which objects can move can be different. Also, different objects can move at the same rate. So if the case is of same rate, then the objects have same speed, and when the rates are different, then the objects will be having different speeds. One of the ways of measuring the rate of motion of an object is to find the distance travelled by the object in unit time, and the quantity is referred to as the speed. So speed is the rate of change of position of an object, and the formula is distance upon time. The SI unit of speed is meter per second, as you can see from the formula also. Next is the formula for calculating average speed, and it is given by total distance travelled upon total time taken. One important point that must be noted over here is that the speed is a scalar quantity. As you can see from the formula, both distance and time are scalar quantities. So the operation between the two scalar quantities will again give you a scalar quantity. Next is speed with direction. So the rate of motion of an object can be more informative if we specify its direction of motion along with its speed. The quantity specifies both these aspects is called velocity. Velocity is the speed of an object moving in a definite direction. The velocity of an object can be uniform or variable. It can be changed by changing the object's speed, direction of motion, or both. When an object is moving along a straight line at a variable speed, we can express the magnitude of its rate of motion in terms of average velocity. So firstly, I will tell you the formula for average velocity. Okay, before that I will tell you the formula for velocity, that is displacement upon time. Fine, this is the general formula. And to calculate the average velocity, you just need to take the arithmetic mean of the initial and final velocities. Initial velocity plus final velocity upon 2. So arithmetic mean you all know na. Again the SI unit of velocity will be meter per second, as you can calculate it from the formula, and velocity is a vector quantity. Why? Because displacement is a vector quantity and time is a scalar quantity, and the operation between a vector and scalar quantity gives you a vector quantity. So that's it for today. I will send you the next part soon. Thank you.